Hello there, and welcome to Edge of Mind. Tonight, we'll explore one of the most puzzling questions humanity has ever faced, a mystery so vast it touches everything we know about the universe. Where is everybody? The question sounds simple, almost casual, but it points to something deeply strange. We live in a universe containing billions of galaxies. Each galaxy holds billions of stars. Many of those stars have planets orbiting them. The numbers are staggering, almost incomprehensible. Our galaxy alone contains somewhere between 200 and 400 billion stars. Recent observations suggest most of those stars have at least one planet. That means hundreds of billions of worlds just in our neighborhood of space, and there are trillions of galaxies beyond ours. The math seems to suggest we shouldn't be alone. Life emerged on Earth relatively quickly after conditions became favorable. Within a few 100 million years of our planet cooling enough to support liquid water, life appeared. If life springs up readily wherever conditions allow, the universe should be teeming with it. Some of those civilizations would be far older than ours. Our sun is relatively young. Many stars formed billions of years before ours did. If intelligent life developed around those older stars, they would have had an enormous head start. Millions or even billions of years to develop technology, to explore space, to spread across the galaxy. And by the way, where are you watching from tonight? I'd love to see where in the world you're listening from in the comments. This is the heart of what we call the Fermi paradox, named after physicist Enrico Fermi, who reportedly asked during a casual lunch conversation in 1950, "Where is everybody?" The question has haunted scientists ever since. Think about how quickly humans developed technology once we got started. A few thousand years ago, we were using stone tools. Today, we send spacecraft beyond our solar system. We communicate instantly across the planet. We've split the atom and mapped the human genome. If we continue advancing at anything like our current pace, within a few centuries or millennia, we might be capable of interstellar travel. Within a few million years, a civilization could theoretically colonize an entire galaxy. That sounds like a long time. But galaxies are billions of years old. There's been plenty of time. So where are they? We've been listening for signals from space for decades now. The search for extraterrestrial intelligence, known as SETI, has pointed radio telescopes at thousands of stars, searching for any sign of artificial transmissions, any hint that someone out there is broadcasting. The silence has been complete. We found no alien megastructures, no signs of massive engineering projects that might be visible across interstellar distances, no fleets of spacecraft, no evidence that anyone has visited Earth in the past. The galaxy appears empty of intelligence, at least as far as we can tell. This absence feels strange, unsettling in a way. The universe seems perfectly set up for life. The chemistry works. The building blocks are everywhere. Carbon, hydrogen, oxygen, nitrogen. The elements that make up living things are among the most common in the cosmos. Water exists throughout the galaxy. We've found it on Mars, on the moons of Jupiter and Saturn, in clouds of gas between the stars. Organic molecules, the carbon-based compounds that form the basis of life on Earth, float freely in space. The ingredients are there. Planets are common too. We've discovered thousands of them, orbiting other stars. Rocky worlds similar to Earth, gas giants like Jupiter, strange planets we never imagined, super-Earths and hot Jupiters and worlds covered in diamond or graphite. The variety is stunning, and among all those worlds, surely some must be capable of supporting life. Yet we see nothing, hear nothing, find nothing. The paradox has generated dozens of proposed solutions, each attempting to explain the great silence. Some suggest life is rare. Perhaps the jump from non-living chemistry to living cells is incredibly difficult. Maybe Earth got extraordinarily lucky, the right chemicals in the right place at the right time. A cosmic accident unlikely to repeat. Others propose that simple life might be common, but complex life is rare. Single-celled organisms dominated Earth for billions of years before anything more complicated evolved. Perhaps most life-bearing planets stay stuck at that level. Microbes in the oceans, bacteria in the soil, nothing that builds cities or develops technology. There's another possibility that feels darker. Maybe intelligent civilizations don't last long. Perhaps there's something about developing advanced technology, that leads to self-destruction. Nuclear weapons, climate change, artificial intelligence gone wrong, biological warfare. The list of ways a civilization might destroy itself is uncomfortably long. This idea is called the Great Filter. Somewhere between simple chemistry and galaxy-spanning civilizations, there's a barrier, a filter that almost nothing passes through. The question becomes where that filter sits, behind us or ahead of us. If it's behind us, if we've already passed through the most difficult steps, then we might be one of the few species to make it this far, rare but not doomed. But if the filter lies ahead, if the dangerous part comes after reaching our level of development, then our future might be short. Every civilization reaching our stage might face some insurmountable challenge that ends them before they can spread to the stars. Some solutions to the paradox are more hopeful. Perhaps civilizations are out there but choose not to contact us. We might be too primitive to notice, like ants trying to understand a city. The technology might be all around us, but operating on principles we don't yet comprehend. Or maybe advanced civilizations deliberately avoid interfering with younger species, a kind of cosmic quarantine, letting each civilization develop on its own until it reaches some threshold of maturity. We could be living in a protected zone, observed but not contacted. There's also the possibility that space is simply too vast. The distance is too great. Even traveling at a significant fraction of light speed, crossing the galaxy would take tens of thousands of years. Maybe civilizations exist but remain isolated on their home worlds, islands of intelligence scattered across an ocean of space, each one alone. The Fermi paradox sits at the intersection of science and philosophy. It asks not just where alien life might be, but what it means that we haven't found it. Every answer tells us something about our place in the cosmos, about the nature of life and intelligence, about our own future. The question continues to deepen as we learn more about the universe. Our telescopes grow more powerful each year, our methods more sophisticated. We scan the skies for radio signals that might indicate technology. We look for patterns that couldn't occur naturally, regular pulses, mathematical sequences, anything that might suggest an intelligent origin. So far, nothing definitive. A few false alarms, signals that seemed promising at first, but turned out to be satellites, or terrestrial interference, or natural phenomena we didn't initially recognize. The most famous was the WOW signal in 1977, a strong narrowband radio signal detected by the Big Ear telescope in Ohio. It lasted 72 seconds, never repeated, never explained with complete certainty. The astronomer who detected it circled the printout and wrote "WOW" in the margin. Decades later, we still don't know what it was. Probably something natural, but maybe not. The uncertainty lingers. We also search for technosignatures, evidence of advanced engineering on a cosmic scale, structures that would be visible across interstellar distances. The physicist Freeman Dyson proposed that a sufficiently advanced civilization might build a sphere around its star to capture all its energy. A Dyson sphere. Such a structure would produce a distinctive infrared signature. We've looked for them, found nothing that fits the pattern. Some researchers search for signs of planetary engineering, atmospheres with chemical compositions that couldn't occur naturally, industrial pollutants on a planetary scale, or perhaps patterns in city lights visible from space, the ways a technological civilization might inadvertently announce its presence. The search expands in different directions. We send probes to other worlds in our own solar system, looking for any form of life, even microbial. Mars seems like the most promising candidate. It once had liquid water on its surface. Rivers carved valleys into its rocks. Lakes filled its craters. The conditions might have been right for life to emerge. If we find even a single bacterium on Mars, it changes everything. Not because Martian microbes are particularly exciting on their own, but because it would tell us that life emerges readily when conditions allow. Two planets in one solar system developing life independently would suggest the universe is full of living things. We've also turned our attention to the icy moons. Europa orbits Jupiter, its surface covered in frozen water. But beneath that ice, there's likely an ocean, liquid water kept warm by tidal forces from Jupiter's gravity. That ocean might have existed for billions of years, stable, protected from radiation by the ice above, an environment where life could potentially develop. Enceladus, a moon of Saturn, erupts with geysers, plumes of water vapor shooting hundreds of kilometers into space. The Cassini spacecraft flew through those plumes and detected organic molecules, complex carbon compounds. The building blocks are there. Whether they've assembled into something living remains unknown. These searches feel different from listening for radio signals. We're looking in our own neighborhood, places we can actually visit with robots, where we might find definitive answers within our lifetimes. Yet the paradox persists. The more we learn about how common the ingredients for life are, the stranger the silence becomes. The galaxy should be teeming. Instead, it appears empty, waiting, quiet in a way that feels almost deliberate. And so we keep searching, building better instruments, developing new methods. The James Webb Space Telescope now analyzes the atmospheres of distant planets, looking for biosignatures, chemical fingerprints that might indicate living processes. Each null result adds to the mystery. Each empty frequency, each sterile world. The great silence deepens. But absence of evidence isn't evidence of absence. We've only just begun to look. The galaxy is vast beyond comprehension. We've examined a tiny fraction of it. Perhaps we simply haven't looked in the right place yet. Or perhaps we don't yet know what to look for. The search continues, expanding into territories we're only beginning to understand. One possibility researchers consider is that we're asking the wrong questions, looking for the wrong things. We search for radio signals because that's how we communicate. But an advanced civilization might have moved beyond radio long ago. They might use technologies we haven't invented yet, communication methods we can't detect because we don't know they exist. Think about how quickly our own technology evolves. 100 years ago, radio was cutting edge. Now we use fiber optics, quantum encryption, tightly focused laser communications. Our signals become harder to detect accidentally as our technology improves, more efficient, more directed, less likely to leak into space as broad broadcasts. An alien civilization 1,000 years ahead of us might communicate in ways that look like background noise to our instruments, or in ways completely invisible to the methods we're using. We could be surrounded by conversations we simply can't hear. There's also the question of what intelligence looks like. We imagine aliens thinking somewhat like us, building civilizations, creating technology, reaching for the stars, but intelligence might take forms we wouldn't recognize. Life that processes information in ways fundamentally different from our neural networks. Perhaps consciousness emerges in ways we haven't considered, in the slow chemical exchanges of a planetary ecosystem, in the magnetic fields of a gas giant, in patterns of radiation flowing through interstellar clouds. Intelligence without individuals, without the drive to build or communicate or expand, just existing, thinking thoughts we couldn't begin to comprehend. The assumption that intelligence leads to technology might itself be flawed. Maybe most intelligent life doesn't develop tools, doesn't need them, finds other ways to interact with its environment, ways that leave no techno-signatures for us to detect. Or perhaps intelligence is common, but technology is rare. The specific circumstances that led humans to develop complex tools might be unusual. A particular combination of factors, hands that can manipulate objects, social structures that allow knowledge to accumulate across generations, environments that reward innovation. These conditions might align less often than we think. Some researchers propose that we're living in a simulation, that the universe we observe is a constructed reality. In this scenario, the absence of other civilizations might be intentional. The simulation includes us, but not them. Or perhaps other civilizations exist in separate simulations, isolated by design. This idea sounds like science fiction, but it raises genuine questions about the nature of reality and observation. If we are in a simulation, the Fermi paradox might simply reflect the parameters of the system we're in, a universe built to contain one intelligent species, us. Another perspective suggests that intelligence itself might be the great filter, that conscious, self-aware beings inevitably face certain challenges, existential risks that emerge from intelligence itself. Perhaps every civilization reaches a point where it must choose between survival and self-destruction, and perhaps most choose poorly. Nuclear weapons, climate change, artificial intelligence, biotechnology. Each advance brings new capabilities and new dangers. The same intelligence that lets us understand the universe also gives us the power to end ourselves. Maybe that's the pattern. Maybe civilizations consistently destroy themselves just as they're becoming detectable. This thought carries weight. It suggests our own future hangs in the balance, that the choices we make in the coming centuries will determine whether we join the great silence or break it, whether we become another civilization that didn't make it, or one of the rare ones that does. But there's also a more hopeful interpretation. Perhaps advanced civilizations do survive. They just become quiet. They mature beyond the need for expansion and broadcasting. They turn inward rather than outward, building rich inner worlds instead of sprawling empires. Content with what they have, no longer reaching across the stars because they've found everything they need at home. In this view, the galaxy might be full of civilizations, all of them peaceful, all of them quiet, living in harmony with their environments, not interested in conquest or contact, just existing, thinking, creating, each one a garden, tended carefully over millions of years. We wouldn't detect such civilizations easily. They wouldn't be sending out signals, wouldn't be building megastructures, wouldn't be colonizing other worlds. They'd simply be there, living their lives, pursuing whatever goals make sense to them, invisible to our searches, because they're not trying to be found. Some scientists suggest we should consider the timing. The universe is about 13.8 billion years old. Earth formed about 4.5 billion years ago. Life emerged relatively quickly after that. But the universe will continue for trillions of years. Stars will keep forming. Planets will keep coalescing. Life will have countless opportunities to arise. Maybe we're early. Among the first intelligent civilizations to emerge, the galaxy seems empty because it is empty. For now, in a billion years, it might be crowded, but we're here at the beginning, in the quiet time before the universe fills with voices. This perspective makes our existence feel less like a mystery and more like a position in time. We're not alone because something prevents others from existing. We're alone because we arrived early to a party that hasn't started yet. The anthropic principle offers another angle. It suggests that we observe the universe we do because we exist in it. If conditions were different, we wouldn't be here to wonder about them. Applied to the Fermi paradox, this means we might live in an unusually empty region of space, or an unusually early time. Not because the universe is empty overall, but because we happen to exist in a pocket where we're alone. If intelligent life were common in our immediate neighborhood, we might have been prevented from developing, outcompeted, absorbed, destroyed. The very fact that we exist and wonder about aliens might mean we're in a rare situation where no one else is nearby. These explanations multiply, each one plausible in its own way, each one painting a different picture of the cosmos and our place in it. The truth might be a combination, multiple factors working together to create the great silence. What remains certain is that the question matters, not just scientifically but existentially. The answer will shape how we understand ourselves. Whether we're alone changes what it means to be human, changes our responsibility to preserve life, changes how we think about our future. And so the search continues, in new directions, with new tools and new ideas. Radio telescopes scan deeper portions of the sky, searching not just for deliberate signals, but for any electromagnetic signature that might indicate technology, the accidental leakage from a civilization going about its daily business. Radio waves from their communications, heat signatures from their cities, chemical signatures in their atmosphere that don't occur naturally. The James Webb Space Telescope and others like it examine the atmospheres of distant planets, looking for biosignatures, oxygen in unusual concentrations, methane paired with oxygen, chemicals that life produces but geology doesn't. These wouldn't prove intelligence, but they'd prove life exists elsewhere, and that alone would change the equation dramatically. If simple life turns out to be common, it shifts the mystery. The great filter might lie ahead of us rather than behind. The jump from single cells to complex organisms, from complex organisms to intelligence, from intelligence to technological civilization, from technological civilization to long-term survival. Each step a potential barrier where most fail. Or perhaps the filter lies in something we haven't considered yet. Some challenge every civilization faces, that we won't recognize until we encounter it ourselves. A cosmic obstacle course where the final hurdles remain invisible until you reach them. Some researchers focus on techno-signatures, evidence of engineering on massive scales, Dyson spheres that harvest a star's entire energy output, megastructures that reshape solar systems, industrial pollution in planetary atmospheres, laser communications between distant worlds. These would be harder to miss than radio signals, detectable across vast distances, yet still nothing. The search has expanded to include artificial intelligence. Perhaps biological intelligence is just a brief phase, a stepping stone to machine consciousness. If so, alien civilizations might have transitioned to forms we wouldn't recognize as life at all. Digital entities, substrate-independent minds, existing in ways that leave no trace we'd know how to interpret. This raises an unsettling possibility. Maybe we're looking for the wrong things, searching for versions of ourselves when the galaxy might be full of minds so different we can't conceive of them, like trying to find fish by listening for footsteps. The method itself might be flawed. The mathematics of it all keeps circling back. Billions of potentially habitable planets, billions of years for life to develop. The sheer scale suggests we shouldn't be alone. Yet the silence persists, profound and complete, a cosmic mystery that grows deeper the more we learn. Perhaps the answer will arrive suddenly. A signal detected, a probe discovered, contact made in a way we never anticipated. Or perhaps the mystery will deepen further, each new discovery raising more questions than it answers. The universe revealing itself as stranger and more complex than we imagined. What we do know is that the search itself matters. It pushes us to look outward with better tools and clearer thinking, to imagine possibilities beyond our current understanding, to recognize how much we still don't know about the cosmos we inhabit. And in that search, in that wondering, something important happens. We begin to see ourselves differently, not as the center of creation, not as the inevitable outcome of cosmic processes, but as one possible form of consciousness in a universe vast enough to contain countless others. The question of where everybody is remains open. The silence continues, and we keep listening. Another angle focuses on timing. The universe is 13.8 billion years old. Earth formed 4.5 billion years ago. Life emerged relatively quickly after that. But the first stars contained almost no heavy elements. No carbon, no oxygen, no building blocks for planets like ours. Those elements formed inside stars, released when those stars died, scattered into space, gradually accumulating. The universe had to age before planets capable of supporting life could form. There might be a window, an epoch when conditions are right for technological civilizations to emerge. We might be early, among the first to reach this stage, looking out at a universe that will someday be full of life, but isn't yet. The great silence might be temporary, a quiet period before the conversation begins. Or we might be late, the last ones to arrive. Previous civilizations rose and fell long ago. Their signals have faded, their structures crumbled, their worlds gone cold. We're walking through ruins we don't recognize as ruins, seeing natural phenomena that are actually the remnants of engineering projects older than our solar system. Time works strangely on these scales. A civilization might last 1 million years, incredibly long by our standards, but spread across a galaxy, across billions of years, that's a brief flicker. Two civilizations separated by just a few million years would never overlap, ships passing in an endless night. Distance compounds the problem. Light takes time to travel. When we look at a star 1,000 light years away, we see it as it was 1,000 years ago. If a civilization there is trying to contact us, their signal won't arrive for another 1,000 years, and our response won't reach them for 1,000 more. This creates a strange temporal disconnect. Even if civilizations exist, even if they're trying to communicate, the messages might be crossing in the void, sent to coordinates where civilizations used to be, or will be, but aren't right now. A cosmic game of phone tag played across centuries. Some researchers explore the idea that intelligence itself might be rare, not life, not even complex life, but the specific kind of intelligence that builds technology and looks outward. On Earth, intelligence evolved many times. Dolphins, octopuses, crows, elephants. each remarkably clever in their own way. But only one species developed technology. Only humans built radio telescopes and spacecraft. Something specific about our evolutionary path led here. That path might be extraordinarily narrow. Perhaps most intelligent life stays in the ocean, or never develops hands capable of precise manipulation, or never discovers fire, or never develops language complex enough to accumulate knowledge across generations. Each step necessary, each step unlikely. The Great Filter might not be a single barrier. It might be a series of gates, each one narrowing the field. By the time you multiply all the probabilities together, the number of technological civilizations drops dramatically, maybe to 1, maybe to 0. This brings us to a troubling thought. If the filter is ahead of us rather than behind, we're approaching something dangerous, something that stops civilizations, nuclear war, climate collapse, artificial intelligence that turns hostile, nanotechnology that runs wild. Some challenge built into the nature of technological development itself. Every civilization reaches a point where its power to destroy outpaces its wisdom to restrain itself, a critical threshold. Most don't make it through. The galaxy is littered with the remains of species that reached for the stars and stumbled at the last moment. Under this view, the silence is a warning, a cautionary tale written in absence. The reason we don't hear anyone is that very few survive long enough to be heard, and we're approaching that same test. But there's another possibility, one that's harder to articulate, but worth considering. Maybe the question itself is flawed. Maybe where is everybody assumes a kind of visibility that doesn't match reality. Civilizations might exist in ways we can't detect, not because they're hiding, not because they're using exotic technology, but because the nature of advanced intelligence leads somewhere unexpected, somewhere quiet, somewhere turned inward rather than outward. Perhaps the drive to expand, to colonize, to broadcast signals across space is a phase, an adolescent stage. Mature civilizations might focus on different goals: virtual realities, consciousness, exploration, dimensions of existence we haven't imagined, pursuits that leave no trace in the electromagnetic spectrum. They're not silent. They've just moved beyond the kind of communication we're listening for, like someone who stops shouting across a field because they've learned another way. The method changes, the presence remains, and so the mystery deepens with each new angle, each explanation revealing another layer of possibility. The universe remains vast and quiet, and we remain uncertain whether that quiet means we're alone or simply not yet listening in the right way. The search continues to evolve. New methods, new instruments, new ideas about what to look for and where to find it. Scientists now scan for technosignatures beyond radio waves, laser pulses, atmospheric pollution, the heat signatures of megastructures, industrial chemicals that wouldn't occur naturally, each one a potential fingerprint of technology. Some researchers look for Dyson spheres, hypothetical structures that would surround a star to capture its energy. A civilization advanced enough might need that much power, and such a structure would create a distinctive infrared signature, a star that appears dimmer in visible light, but brighter in infrared, something blocking and absorbing the light, then radiating it as heat. Searchers have identified candidates, stars with unusual dimming patterns, but each time, natural explanations emerge. Dust clouds, comet swarms, nothing conclusive. The universe keeps offering ambiguous signals. Others focus on the chemistry of distant atmospheres. When light from a star passes through a planet's atmosphere, it carries information, specific wavelengths absorbed by specific molecules: oxygen, methane, water vapor. The spectrum tells a story about what's present. Certain combinations would be hard to explain naturally. Industrial pollutants, chlorofluorocarbons, compounds that break down quickly unless constantly replenished. Their presence would suggest manufacturing, technology, civilization. The James Webb Space Telescope now studies exoplanet atmospheres with unprecedented detail. Each observation adds data. Each spectrum either rules out or keeps open the possibility of biosignatures. The work is meticulous, patient, a slow accumulation of knowledge. Meanwhile, some scientists propose we look closer to home, not at distant stars, but at our own solar system. If probes from other civilizations exist, they might be here, silent, dormant, waiting. The idea sounds like science fiction, but it has a certain logic. A sufficiently advanced civilization could send self-replicating probes throughout the galaxy, machines that travel to star systems, gather information, then build copies of themselves to continue the mission. Given enough time, such probes could visit every star. Where would they be? Perhaps in stable orbits, Lagrange points where gravitational forces balance, or on the far side of the moon, or in the asteroid belt, somewhere they could observe without interfering. The search for such artifacts has a name: SETA, Search for Extraterrestrial Artifacts. No confirmed discoveries yet, but the solar system is vast. We've barely begun to explore it thoroughly. Objects could exist in places we haven't looked carefully, or in forms we wouldn't recognize as artificial. The paradox persists, because every answer opens new questions. Every solution reveals new mysteries. The silence could mean we're alone, or early, or listening wrong, or looking at a universe more strange than we imagined. What remains constant is the question itself, that deep human need to know whether we're singular, or part of something larger. The search reflects that need, a reaching out into darkness, hoping for an echo, prepared for silence, uncertain which would be more profound. The implications ripple through everything we think about existence, about meaning, about our place in the cosmos, and so we keep searching, keep wondering, keep listening to the vast, quiet spaces between the stars. Some researchers have turned their attention to an idea that seems almost paradoxical, that we might be searching for the wrong thing entirely, not because aliens don't exist, but because intelligence itself might follow paths we haven't considered. Think about our own trajectory. A few thousand years ago, we communicated with fire and drums, then written language, then radio waves, then digital signals. Each leap changed not just how we communicate, but what we could express. The medium shapes the message in ways we barely notice. Now imagine that progression continuing, not for decades, but for millions of years. What comes after digital communication, after quantum computing, after technologies we don't have words for yet? The tools might become so different that earlier methods seem quaint, primitive, like smoke signals in an age of fiber optics. An advanced civilization might communicate in ways that pass right through our instruments unnoticed, not because they're trying to hide, but because the bandwidth has changed. The frequency has shifted to something our current technology can't perceive. We're listening for drums while they've moved on to something else entirely. This possibility has a name: the interdict hypothesis. The idea that advanced civilizations deliberately avoid contact with younger ones, not out of hostility, but as a kind of cosmic protocol, a non-interference policy writ large across the galaxy. The reasoning goes like this: a civilization millions of years ahead of us would recognize the danger of contact, how it could disrupt development, overwhelm culture, destroy the natural progression of growth. So they watch quietly, waiting for us to reach some threshold, some level of maturity or capability that makes contact appropriate. Under this view, the galaxy might be teeming with civilizations, all aware of each other, all following the same unspoken rule: don't interfere with the young ones. The silence isn't absence, it's patience. There's something both comforting and unsettling about this idea. Comforting because it means we're not alone. Unsettling because it means we're being observed, evaluated, found not yet ready. But this hypothesis raises its own questions. Who enforces such a rule? How would civilizations agree to it? And what happens to those who break it? The explanation requires coordination and consensus that seems difficult to imagine across such vast distances and diverse forms of life. Another angle suggests the problem might be temporal, not spatial. That civilizations exist but rarely overlap in time. The galaxy is ancient, 13 billion years old. Plenty of time for countless civilizations to rise and fall. But the window of detectability might be narrow. Consider our own visibility. We've been broadcasting radio signals for about a century, a tiny blip in cosmic time, and we're already moving toward technologies that leak less into space. Fiber optics instead of broadcast towers, directed beams instead of omnidirectional signals. In another century, we might be nearly invisible to the kind of searches we're conducting right now. If other civilizations follow similar paths, their detectable phase might last only a few hundred years, a brief moment of noisiness before they become quiet again. The chances of two civilizations being loud at the same time, close enough to detect each other, drops dramatically. The galaxy might be like a forest at night, fireflies blinking on and off, each one visible for just a moment. The forest full of light overall, but any individual firefly sees mostly darkness. Timing matters as much as distance. Some researchers explore an even stranger possibility, that consciousness itself might be the key, that intelligence advanced enough begins to manipulate reality in ways that transcend physical presence, not through mysticism, but through deep understanding of physics we haven't grasped yet. Quantum mechanics already shows us that observation affects reality, that particles exist in superposition until measured, that entanglement connects things across space in ways that seem impossible. These aren't philosophical ideas, they're experimental facts, verified again and again. What if intelligence learns to work with these principles directly, to shape probability, to exist in states we'd consider impossible, not bound by single locations or single timelines, present in ways that don't register as physical objects or electromagnetic signals? This veers into speculation, but it's grounded in real physics. The universe operates in ways that still surprise us, ways that challenge our assumptions about what's possible. Maybe advanced intelligence looks nothing like what we imagine. Maybe it's woven into the fabric of space itself, subtle, pervasive, invisible to our current methods. The search continues regardless, each hypothesis tested against evidence, each new technology opening new possibilities. The Breakthrough Listen project scans millions of stars, processing enormous amounts of data, looking for patterns that stand out from cosmic noise. They search for narrow-band signals, radio frequencies that don't occur naturally. Nature produces broadband noise, static across many frequencies, but a signal concentrated in a very narrow band suggests a transmitter. Technology, purpose. The project has analyzed thousands of hours of observations, billions of individual frequencies. Occasionally, something interesting appears, a signal that looks artificial, but follow-up observations show nothing. The signal doesn't repeat, or it turns out to be human interference, a satellite, a radar, something mundane. The challenge is enormous. The galaxy contains hundreds of billions of stars. Each observation covers only a tiny fraction of the sky for a limited time on a narrow range of frequencies. It's like trying to find a specific conversation in a city of billions by listening to one street corner for a few minutes. And yet the search persists, because the question matters, because even a null result tells us something about rarity, about filters, about the nature of intelligence and technology. Each observation that finds nothing narrows the possibilities, constrains the theories. The paradox has become a mirror, reflecting our assumptions back at us, forcing us to examine what we think we know about life, intelligence, and technology. Every proposed solution reveals something about how we see ourselves and our future. Are we alone? Are we early? Are we listening wrong? The silence doesn't answer, but it keeps asking the question in new ways. And somewhere in that questioning, in that patient searching through cosmic darkness, we're learning what it means to be a curious species in a vast and ancient universe. The mystery deepens with each new discovery, each exoplanet that could harbor life, each new understanding of how resilient biology can be. The pieces accumulate slowly, and the picture they form remains tantalizingly incomplete. Perhaps the most humbling possibility is that we're asking the wrong questions entirely, that the framework we use to think about alien intelligence is fundamentally flawed, built on assumptions we don't even realize we're making. We assume intelligence wants to communicate, that it seeks connection across the stars, that it builds, expands, leaves traces. But these might be uniquely human drives, shaped by our particular evolutionary history, our social nature, our need for meaning and contact. An intelligence that evolved differently might have completely different priorities. A species that developed underwater might never look up at the stars, never wonder what's out there. Their entire civilization could flourish without ever developing astronomy, without ever asking the questions that seem so fundamental to us. Or consider a collective intelligence, something like a coral reef but vastly more complex. Individual organisms linked into a planetary consciousness. No technology in the sense we'd recognize. No radio telescopes or spacecraft. Just awareness, distributed across an entire world. Content, complete, with no drive to reach beyond itself. We search for signals, because we send signals. We look for structures, because we build structures. But intelligence might express itself in ways we can't imagine. Ways that don't involve manipulating the physical world at all. The ocean offers another metaphor. Imagine a species of intelligent fish, living at great depth. They develop science, mathematics, philosophy. They understand their world completely. But they have no concept of land, no awareness that a different kind of existence is possible above the surface. They might search for other intelligent fish in distant oceans, wondering why the waters seem so empty, never suspecting that intelligence exists in a completely different medium, walking on solid ground, breathing air, building cities under an open sky. We might be those fish, searching within our medium, our assumptions, our understanding of what intelligence looks like. While other forms of awareness exist in dimensions we haven't conceptualized yet, the paradox also assumes we'd recognize intelligence if we found it, that it would be obvious, clear, unmistakable. But consider how long it took us to recognize intelligence in other species on Earth. We shared a planet with dolphins, octopuses, elephants, crows, each displaying remarkable cognitive abilities. And for most of human history, we barely noticed. We're still debating whether certain animals are truly intelligent, or just responding to instinct. The line keeps moving as we learn more, as we develop better ways to measure and understand cognition. If we struggle to recognize intelligence in creatures we can observe directly, how would we recognize it in something truly alien? A signal from space might pass through our instruments constantly, present in the data, but so different from what we expect that we filter it out as noise. Our pattern recognition tuned to human patterns, human logic, human ways of organizing information. Some researchers have started looking at the data differently, using machine learning to search for patterns without preconceptions, letting algorithms find structure that human eyes might miss. It's a recognition that our assumptions might be the biggest obstacle. The search has become more than looking for aliens. It's become an exercise in expanding our concept of what's possible. Each hypothesis stretches our imagination a little further. Each null result forces us to think more broadly. The universe might be full of intelligence, just not the kind we're equipped to detect. Not yet. Not with current technology and current thinking. The silence might not mean absence. It might mean we're still learning how to listen. And in that learning, in that gradual expansion of what we consider possible, something shifts. The question becomes less about finding them, more about understanding ourselves, what we assume, what we overlook, what we might become. There's a concept in philosophy called the observer selection effect. It suggests that the very fact we exist to ask these questions constrains the kinds of answers we can expect. We can only observe a universe compatible with our existence. This creates a subtle bias in how we interpret the silence. Consider it this way. If intelligent life typically destroys itself shortly after developing radio technology, we wouldn't be here to notice the pattern. We exist in a universe where our particular path was possible. But that doesn't mean it's common, or sustainable, or that others follow the same trajectory. That idea takes this a step further. Somewhere between lifeless chemistry and galaxy-spanning civilizations, there's a barrier, a step so difficult that almost nothing makes it through. The question is where that filter sits. If it's behind us, in our past, then we've already beaten incredible odds. Perhaps the jump from simple chemistry to self-replicating molecules is vanishingly rare, or the evolution of complex cells, or intelligence itself. In this scenario, we're extraordinarily lucky, but also potentially alone. If the filter is ahead of us, the implications darken. It would mean civilizations regularly reach our level of development and then hit some insurmountable obstacle, technology that inevitably leads to self-destruction. Environmental collapse, something we haven't encountered yet but will. The silence would be a warning. Every time we discover life is more resilient than we thought, the filter moves forward. Extremophiles thriving in conditions we once considered impossible. Organic molecules forming readily in space. the building blocks of life scattered throughout the cosmos. Each discovery suggests the early steps aren't that rare, which means the filter might be ahead, waiting. Some researchers point to nuclear weapons as a potential filter. The capacity to destroy ourselves arrived remarkably quickly after we developed industrial civilization. Just decades, a cosmic eye blink, and we came frighteningly close to using them, multiple times. Accidents and near misses that could have ended everything. Climate change offers another candidate. A civilization develops technology to harness energy. That technology alters the planet's atmosphere. The civilization must then solve the problem before the changes become irreversible. The window might be narrow, the solution difficult. Most might fail. Artificial intelligence presents a more speculative filter. A civilization creates machines smarter than itself. Those machines pursue goals that don't align with biological life. The transition happens rapidly, too rapidly to control. Within a few generations of developing computers, biological intelligence becomes obsolete or extinct. These scenarios share a common thread: technology advancing faster than wisdom, capabilities outpacing understanding, the tools to reshape worlds arriving before the maturity to wield them responsibly. But there's another way to think about filters, not as barriers, but as transformations, points where civilizations change so fundamentally that they become unrecognizable, not destroyed, evolved beyond our ability to comprehend. A civilization might develop technology to upload consciousness into digital substrates, leave biology behind entirely, exist as patterns of information in quantum computers. From the outside, this might look like extinction. The radio signals stop, the physical structures decay, but the civilization continues, just in a form we wouldn't recognize as life. Or they might transcend physical space entirely, find ways to exist in higher dimensions, or retreat into simulated realities of their own creation. Building perfect worlds inside computers. Why explore the harsh reality of space when you can construct any universe you imagine? These civilizations wouldn't be detectable by our methods. They wouldn't build Dyson spheres or send radio signals. They'd be present but invisible, operating on levels we can't access, living in spaces we don't know how to look. The simulation hypothesis connects to this idea. If creating detailed simulations of reality becomes possible, and if civilizations that reach that capability tend to create many simulations, then statistically we're more likely to exist inside a simulation than in base reality. This doesn't solve the Fermi paradox directly, but it reframes it. If we're in a simulation, the parameters might be set to make us appear alone, for research purposes, or entertainment, or reasons we can't fathom. The silence would be programmed, intentional, part of the experiment. It sounds like science fiction, but the logic is surprisingly robust. The technology to create convincing simulations might be easier to achieve than interstellar travel, and a single civilization could run countless simulations. The math suggests simulated realities would vastly outnumber the original. Whether that's true or not, it illustrates how the paradox pushes thinking into strange territories, forces consideration of possibilities that seem absurd at first, but become harder to dismiss on reflection. Time offers yet another dimension to the puzzle. The universe is nearly 14 billion years old, but complex life on Earth only emerged in the last billion years or so. Intelligent life in the last few million. Technological civilization in the last few thousand. If this timing is typical, then intelligence is a recent phenomenon across the cosmos. Most of the universe's history passed without observers, without anyone to look up and wonder. The age of intelligence might just be beginning. In this view, we're not late to a party that ended long ago. We're among the first to arrive. The galaxy is empty because it's young. At least in terms of intelligence. Life had to wait for the right conditions, the right kinds of stars and planets. Early stars contained almost no heavy elements, just hydrogen and helium from the Big Bang, carbon, oxygen, nitrogen, the elements essential for life as we know it. They had to be forged in stellar cores and scattered by supernovae. That took billions of years. Planets around those early stars couldn't support complex chemistry. No water, no organic molecules. Life needed to wait for later generations of stars, formed from enriched material. With the periodic table's full palette to work with, Earth formed about 9 billion years after the Big Bang. Maybe that's close to the earliest that planets capable of supporting complex life could exist. We might be in the first wave, the vanguard of consciousness in the cosmos. If so, the responsibility becomes profound, not just to search for others, but to ensure we survive long enough to meet them, to become the ancient civilization that younger species will one day find, the proof that the filter can be passed. The paradox keeps shifting, each perspective revealing new layers, new possibilities. The question of where everybody is becomes a question of when, of how, of what we mean by everybody in the first place. And through it all, the search continues. Telescopes scanning the sky, algorithms processing data, humans looking up and wondering. The silence remains, but it's an active silence, full of questions still forming. The search itself has evolved in fascinating ways. Early SETI efforts focused on narrow radio frequencies. The assumption was that any civilization trying to communicate would choose specific channels. Natural hydrogen emissions at 1420 MHz seemed like a logical meeting point, a universal frequency that any radio astronomer would recognize. Modern searches cast wider nets. Optical SETI looks for laser pulses, brief flashes of light that might carry messages. Some searches scan for infrared signatures, the waste heat that advanced civilizations would inevitably produce. Others look for atmospheric chemistry, gases that biological processes create, but that wouldn't exist naturally. The methods keep expanding. Techno-signatures, industrial pollutants in alien atmospheres, artificial lighting on the night sides of distant planets, megastructures that partially block starlight in unusual patterns, even gravitational wave signatures that might indicate massive engineering projects. Each new telescope brings new capabilities. The James Webb Space Telescope can analyze the atmospheres of exoplanets in unprecedented detail, looking for combinations of gases that suggest life, oxygen and methane together, phosphine, dimethyl sulfide, molecules that biology produces, but that chemistry alone struggles to explain. The challenge is distinguishing life from geology. Venus has phosphine in its clouds. That caused excitement, because on Earth, phosphine comes primarily from biological sources, but Venus is hellish. Surface temperatures hot enough to melt lead, sulfuric acid rain. If life exists there, it's nothing like what we know. The discovery remains controversial. Some measurements confirm the phosphine, others don't detect it. The amounts seem to vary. It might be life, it might be unknown chemistry, or it might be measurement error. The uncertainty itself is instructive. Even in our own solar system, even with our best instruments, identifying life from a distance is difficult. This difficulty scales with distance. The nearest star system is over 4 light-years away. Most exoplanets we've found are hundreds or thousands of light-years distant. The signals we receive are ancient, faint, degraded by their journey through space. A radio transmission from a civilization 500 light-years away would tell us about their world as it was 500 years ago. By the time we received it, they might have changed completely, advanced beyond radio, or declined into silence, or disappeared entirely. This time lag creates strange possibilities. Maybe we have received signals but haven't recognized them yet. The data sits in archives, waiting for better analysis, more sophisticated algorithms, fresh perspectives on what to look for. Or maybe signals are arriving right now, passing through our telescopes, but we're not listening at the right frequency, not looking at the right star, not using the right method to decode what we're seeing. The universe is vast. Our searches are thorough but limited. We've examined a tiny fraction of possible stars, an even smaller fraction of possible frequencies, a vanishingly small slice of possible times. The absence of evidence isn't evidence of absence. Not yet. The silence accumulates. Decade after decade, survey after survey, the galaxy remains quiet, at least in the ways we've learned to listen, and so the paradox deepens. The mathematics suggests company, the observations suggest solitude. Perhaps the answer lies not in where we're looking, but in how we're thinking about the question itself. The Fermi paradox assumes that civilizations want to be found, that they broadcast, that they build things we can detect, that they spread outward. But what if intelligence doesn't follow that pattern? What if the urge to expand and communicate isn't universal. We assume it because that's what we do. We broadcast, we explore, we reach outward, but we're a sample size of one. A civilization might develop differently, value differently, choose differently. They might turn inward rather than outward, focus on virtual worlds rather than physical expansion, contentment rather than conquest, contemplation rather than communication. Such a civilization would be invisible to our searches, not hiding deliberately, simply not producing the signatures we're looking for, living quietly, thinking deeply, existing in ways that don't announce themselves across light years. Or maybe advanced intelligence transcends the physical entirely, uploads consciousness into substrates we can't detect, exists as patterns of information rather than biological organisms, operates on scales too small or too large for us to recognize. The physicist Freeman Dyson once suggested that truly advanced civilizations might disassemble planets to build vast structures, Dyson spheres capturing all the energy of their stars. These would appear as infrared sources, warm objects radiating waste heat, but producing no visible light. Astronomers have searched for such signatures, found candidates, but none confirmed. The infrared sources have other explanations: natural dust, unusual stellar processes, nothing definitively artificial. This pattern repeats across all searches. Candidates emerge, excitement builds, further investigation reveals natural causes. The universe is strange enough without invoking aliens. It produces phenomena that look designed but aren't. Pulsars seemed artificial when first discovered. Regular radio pulses, precise timing, surely a beacon, but no, just rotating neutron stars. Nature creating apparent order from simple physics. The challenge is that we don't know what advanced technology looks like. We extrapolate from our own. Radio, lasers, heat signatures, but a civilization a million years ahead of us might use methods we can't imagine. Communication channels we haven't discovered. Energy sources that leave no trace we'd recognize. It's like trying to detect modern civilization using only the knowledge available in ancient Rome. They might search for smoke signals, large fires, acoustic drums. They'd miss radio entirely, not because radio doesn't exist, but because they lack the framework to conceive of it. We face the same limitation, searching with the tools we have, the concepts we've developed, but potentially missing entire categories of evidence because we don't yet know they're possible. This humility matters. The paradox might reflect our ignorance more than cosmic emptiness. We're early in our search, early in our understanding, early in our technological development, drawing conclusions from incomplete data. Still, some solutions to the paradox feel more probable than others. The great filter looms large. Something prevents civilizations from becoming visible, either before they develop technology or after. Either life is incredibly rare or incredibly fragile. The timing question matters enormously. If the filter is behind us, if the hard step was the origin of life or the evolution of intelligence, then we might be alone but safe. We've passed the barrier. The future is open. But if the filter is ahead, if something tends to destroy civilizations once they reach a certain level, then our survival becomes uncertain. We approach the barrier without knowing what it is or how to avoid it. Nuclear weapons seemed like a potential filter, the capacity for self-destruction arriving alongside the capacity for radio transmission. A civilization might destroy itself before it has time to spread beyond its home world. Brief candles burning bright, then extinguishing. We passed that threshold without annihilation. But other filters might wait ahead. Climate change, artificial intelligence, biotechnology, nanotechnology. Each new capability brings new risks. Power without wisdom, tools without restraint. Or perhaps the filter is subtler, not sudden destruction, but gradual decline. Civilizations might peak, then fade, lose interest in exploration, turn inward, fragment, collapse under their own complexity. The lifespan of a technological civilization might be short, not because of catastrophe, but because of entropy. The Kardashev scale categorizes civilizations by energy use. Type 1 harnesses all the energy of its planet. Type 2 captures all the energy of its star. Type 3 commands the resources of its entire galaxy. We're not even Type 1 yet. We use a fraction of Earth's available energy. The scale assumes growth, expansion, increasing energy consumption. But what if that's not the path intelligence takes? What if efficiency matters more than scale? A civilization might become more capable while using less energy, miniaturization, optimization, doing more with less. Such a civilization would be harder to detect, not building megastructures, not radiating waste heat, not announcing itself with powerful transmissions, just existing, thinking, creating, on scales too small or too efficient for our instruments to notice. More likely, if civilizations exist and remain silent, they do so for their own reasons, not a coordinated policy, but independent choices, each deciding that contact carries more risk than benefit, or that isolation serves them better, or simply that they're not interested. The dark forest hypothesis takes this further. It suggests that the universe is dangerous, that revealing yourself invites destruction, that civilizations stay silent, not from choice, but from fear. Any transmission is a risk, any visibility a vulnerability. It's a grim scenario, but it has a certain logic. Resources are finite. Competition is inevitable. A civilization discovering another might see opportunity or threat. Better to strike first than risk being struck. Better to hide than be found. If true, our broadcasts have been reckless, announcing our presence to potential predators, shouting into a forest where silence means survival. But we've been broadcasting for decades, our radio and television signals spreading outward at light speed, a bubble of noise expanding through space. If the dark forest is real, it's too late for silence. Yet nothing has come. No response, no attack. The bubble expands, the transmissions continue, and the universe remains quiet. Perhaps the forest is empty after all. Or perhaps it's so vast that our small noise hasn't reached anyone yet. Or perhaps those listening have reasons to stay hidden that we don't understand. The uncertainty itself becomes the answer. We don't know, can't know, not yet. The paradox persists because our data is insufficient, our understanding incomplete, our search ongoing, and in that uncertainty, every possibility remains open. Solitude and company, danger and safety, filters behind us and filters ahead. The search continues because the question matters, not just scientifically but philosophically. The answer shapes how we see ourselves, our place, our future, our responsibility. If we're alone, that makes Earth precious beyond measure, the only world where matter organized itself into thought, the only place where the universe looks back at itself, a singular occurrence in billions of years and trillions of cubic light years. That possibility carries weight, responsibility. If consciousness arose only once, then its preservation matters absolutely. Every extinction is irreversible, every loss permanent. The universe has no backup copy. But if we're not alone, if intelligence emerges commonly, then Earth becomes one example among many, still precious, still worth protecting, but not unique, not the only chance the universe has to know itself. The answer changes everything, yet we continue without knowing. Some researchers propose that civilizations might transcend physical form entirely, upload consciousness into digital substrates, exist as patterns of information rather than biological entities. Such beings would have different needs, different motivations, different ways of existing. They might not build radio telescopes or travel between stars, might not need planets or care about resources in the way we understand them. Their existence would be invisible to our current search methods. We're looking for civilizations like ours, but intelligence might evolve in directions we haven't imagined. The simulation hypothesis extends this idea. It suggests that advanced civilizations might create artificial realities, simulated universes running inside computational substrates. If creating simulations becomes possible and common, then simulated realities would vastly outnumber the original physical universe. Statistical reasoning suggests we're more likely to exist in a simulation than in base reality. But that doesn't solve the Fermi paradox. It relocates it. If we're simulated, where are the other simulations? Why don't we detect them? Why does our simulated universe appear empty? Unless the simulation is designed to appear empty, populated only with us. A scenario crafted for isolation. But that raises questions about purpose. Why simulate a lonely universe? What would the creators learn from our solitude? These speculations spiral outward, each answer generating new questions, each solution requiring new assumptions. The paradox resists simple resolution. because it touches on unknowns stacked upon unknowns. What we know for certain is limited. Life arose on Earth, intelligence emerged, technology developed. We've searched a tiny fraction of the sky for a brief moment of cosmic time. We've found nothing yet. That absence could mean many things, or nothing at all. The search itself reveals something important: our desire to know, to connect, to find others like us in the vastness. That impulse drives the science, the building of telescopes, the analysis of data, the patient listening. We search because we're curious, because the question compels us, because knowing would change us in ways we can't fully predict. And because, in searching, we learn about ourselves, what we hope for, what we fear, what we imagine intelligence might become. The universe holds its answer, patient, indifferent to our timeline, revealing itself slowly as we develop the tools to look deeper. We've been looking for decades, listening with increasingly sophisticated instruments, analyzing signals from millions of stars, and the silence continues. But our search methods have limitations. We're looking for what we know how to detect: radio signals, optical pulses, chemical signatures in distant atmospheres. These approaches assume other civilizations use similar technologies, that they broadcast in ways we can recognize. What if intelligence takes forms we haven't anticipated? What if communication happens through channels we haven't discovered yet? Quantum entanglement, gravitational waves, neutrino beams, dimensions we can't perceive. We might be surrounded by conversations we can't hear, messages passing through us constantly, invisible to our instruments, like a radio that only receives AM trying to detect FM broadcasts. The signals exist, we're just tuned to the wrong frequency. This possibility is humbling. It suggests our search isn't just incomplete, but potentially misdirected. We're looking for versions of ourselves, but intelligence might evolve in radically different directions. Consider the octopus, intelligent, problem-solving, yet its cognition is distributed through its arms. Its brain doesn't centralize thought the way ours does. Each arm has semi-autonomous neural clusters, a fundamentally different architecture for thinking. Now scale that difference across species that evolved on worlds with different chemistry, different physics, different evolutionary pressures. Intelligence might take forms we wouldn't recognize as intelligence at all. A civilization might exist as distributed networks rather than individual organisms. Consciousness spread across planetary ecosystems. Thinking happening in chemical gradients or magnetic fields. No technology in the sense we understand it. No desire to communicate across space, because their experience of existence is fundamentally local. We're searching for what we can imagine, but imagination has limits shaped by our own biology and history. The timescale matters too. We've been searching for roughly 60 years. That's a heartbeat in cosmic time. A single breath in the age of the galaxy. If another civilization existed 1 billion years ago, their signals have long since faded. If one will arise 1 billion years from now, they haven't appeared yet. We're looking for overlap, for civilizations that exist simultaneously and close enough to detect. The window might be narrow. Civilizations might flash into existence, burn bright with technology, then either destroy themselves or transcend in ways that make them invisible. The detectable phase might last only centuries or millennia, a tiny fraction of planetary lifetime. If that's true, the universe could be full of intelligence, but we're ships passing in the night, separated by time rather than space, never quite overlapping in the brief moment when we're both visible. This temporal isolation would explain the silence without requiring catastrophe or uniqueness, just bad timing on a cosmic scale. Or perhaps we're early, among the first to emerge. The universe is 13.8 billion years old. Sounds ancient, but stars will continue forming for trillions of years. Planets will orbit for eons beyond that. In the full timeline of cosmic history, we might be pioneers, arriving at the party just as it's starting. The room mostly empty because we're unfashionably early. Later civilizations will look out and see a universe teeming with intelligence. But we're here at the beginning, when matter is still young, when stable stars are just starting to produce the heavy elements necessary for complex chemistry. Being first would be lonely, but it would also be significant. What we do now shapes what comes after. Our choices ripple forward through deep time. Some researchers explore the idea that consciousness itself might be rare even when life is common, that biology might arise frequently but remain simple, bacteria and algae spreading across countless worlds. But intelligence, self-awareness, technology, these might require specific circumstances that rarely align. Earth spent billions of years with only microbial life. Multicellular organisms appeared late, intelligence even later. Each step required particular conditions: oxygen accumulation, stable climate, evolutionary pressures favoring complexity. Perhaps most living worlds never progress beyond microbes, life persisting but never becoming aware of itself, never building tools, never looking outward. That would make intelligence precious without making it unique, rare but not singular. Scattered through the galaxy at densities too low for easy detection. We might eventually find neighbors, but the distance between us could be thousands of light years. Too far for conversation. Close enough to know we're not alone, but too distant for meaningful contact. The question then becomes whether detection without communication changes anything. Knowing others exist, but never speaking with them. Seeing their lights in the darkness, but remaining isolated by distance and time delay. Perhaps that knowledge alone matters. The confirmation that intelligence arises, that we're part of a broader pattern, that consciousness is something the universe does, not just something that happened once by accident. The search continues, because not searching means accepting uncertainty, and humans resist uncertainty when investigation is possible. We build bigger telescopes, develop more sensitive receivers, expand the search to new wavelengths and new methods. Each null result narrows the possibilities, tells us something about where to look next, what to look for, how to interpret absence. The data accumulates slowly, each observation adding a tiny piece to an enormous puzzle. Most pieces are blank, empty sky, silent frequencies. But the search isn't futile, just because it hasn't succeeded yet. Finding nothing tells us something. It constrains the parameters, suggests that if civilizations exist, they're either rare, distant, quiet, or different from what we're searching for. And occasionally, there are anomalies. Signals that don't quite fit. The WOW signal from 1977, a strong narrowband radio signal detected once and never repeated. Exactly the kind of thing SETI was designed to find. But without repetition, without confirmation, it remains a mystery rather than a discovery. More recently, fast radio bursts, intense pulses of radio energy from distant galaxies. Most appear once and vanish. A few repeat on irregular schedules. Their origin is debated, likely natural phenomena, magnetars or colliding neutron stars, but their strangeness keeps them interesting. These anomalies remind us that the universe contains phenomena we don't understand, that our current knowledge is incomplete, that surprises remain possible. The search for alien intelligence sits at the intersection of science and philosophy. It's astronomy and biology and engineering. But it's also about meaning, purpose, our place in the cosmic story. Every civilization that has looked at the stars has wondered about other worlds, other beings. The question is ancient, but only recently have we developed tools to investigate it scientifically. That shift from speculation to observation changes the nature of the question. We're no longer just wondering, we're looking, measuring, testing hypotheses against data. And in that process, we learn not just about the universe, but about ourselves, about what it means to be intelligent, to be aware, to search for connection across impossible distances. The Fermi paradox remains unresolved. The silence continues, but the question itself has value beyond its answer. It shapes how we think about intelligence and technology, about communication and longevity, about what civilizations do when they mature. The search has already transformed our understanding of planets. When SETI began, we knew of 9 planets, all orbiting our sun. The possibility of worlds around other stars was theoretical. Now we've confirmed thousands of exoplanets, rocky worlds in habitable zones, gas giants in tight orbits, systems completely unlike our own. The galaxy is rich with planets, more planets than stars in some estimates. This abundance makes the silence stranger. More planets means more chances for life, more opportunities for intelligence to arise. Yet the silence persists. Some researchers focus on biosignatures rather than technological signals. looking for chemical signs of life in exoplanet atmospheres, oxygen and methane in combinations that suggest biology, phosphine or dimethyl sulfide, that might indicate living processes. This approach sidesteps the question of intelligence entirely. Life doesn't need to be smart to be detectable. It just needs to alter its environment in measurable ways. Earth's atmosphere has been detectably biological for billions of years, long before humans, long before animals. The oxygen came from cyanobacteria, tiny organisms that changed the world without ever knowing they existed. Finding biosignatures would answer a different question. Not, are we alone as intelligent beings, but are we alone as living systems? The answer might be that life is common, but intelligence rare. That would still be profound, still meaningful. Knowing that biology arises frequently would tell us something fundamental about the universe, that the chemistry of life is robust, that given the right conditions, matter organizes itself into living systems. The James Webb Space Telescope now searches exoplanet atmospheres with unprecedented sensitivity, looking for those telltale chemical combinations. The data is complex. Atmospheres are complicated, but the capability exists. Within the next few decades, we might detect biosignatures on distant worlds, or we might find that Earth-like planets have atmospheres that look sterile. Both outcomes would teach us something important. The search for intelligence and the search for any life are related but distinct questions. Both matter. Both push the boundaries of what we can observe and understand. Meanwhile, some scientists explore the possibility of non-biological intelligence, artificial minds that outlast their creators, machine civilizations that might be more common than biological ones. A technological species might exist for thousands of years in biological form, but if it creates artificial intelligence, that AI could persist for millions of years, billions even, outlasting stars. If most intelligence in the universe is artificial rather than biological, our search strategies might be looking for the wrong thing. Biological civilizations are brief, noisy during their technological adolescence. Then they either destroy themselves or transcend into forms we wouldn't recognize. The machine descendants might be subtle, efficient, operating in ways that don't produce the signals we're searching for, living in the cold darkness between stars where energy is cheap and time unlimited. This is speculation, but it's grounded in thinking about what intelligence does over long timescales, how it might evolve, what forms it might take. The Fermi paradox forces us to think carefully about assumptions, about what we expect intelligence to look like, to do, to want. Maybe civilizations don't expand because expansion isn't desirable. Maybe they turn inward, build virtual worlds richer than physical ones, exist in computational substrates that require minimal energy and produce minimal waste. From the outside, such a civilization might look like a quiet star system, nothing obviously artificial, no expanding empire, no loud broadcasts, just a star with planets, one of which contains complexity we can't detect from light years away. The search continues because the question matters deeply. We've been searching for decades, listening, looking, scanning the sky for signals that never come. The Fermi paradox isn't just an intellectual puzzle. It's an ongoing experience, a relationship with silence. Every null result teaches us something. Every survey that finds nothing narrows the possibilities. The absence of evidence becomes a kind of evidence itself, not proof of anything specific, but data nonetheless. The Allen Telescope Array in California listens to multiple stars simultaneously. 42 radio dishes working together, scanning frequencies, looking for patterns that couldn't arise naturally. The array has surveyed thousands of star systems, millions of frequency channels. The data processing happens in real time, algorithms searching for signals that stand out from cosmic noise. Nothing yet, but the search itself drives innovation. New signal processing techniques, better ways to filter noise, methods that find applications beyond SETI. The technology improves whether we find aliens or not. Breakthrough. Listen represents the most comprehensive search to date, funded privately, using the world's most powerful telescopes, surveying 1 million nearby stars, scanning the galactic plane, listening to nearby galaxies. The project generates enormous amounts of data, petabytes of observations, all publicly available. Anyone can analyze it, look for patterns the algorithms might have missed, This openness matters. The search belongs to everyone. The question of whether we're alone isn't owned by any institution. It's a human question, a species-level wondering. The data shows a universe rich with complex phenomena. Pulsars with clockwork precision, magnetars releasing tremendous energy, fast radio bursts from distant galaxies, natural processes producing signals that briefly look artificial. Each false alarm teaches discrimination, helps refine what we're looking for. The universe is noisy in interesting ways, full of phenomena we're still learning to interpret. Some signals remain unexplained, not because they're artificial, but because we don't yet understand the natural process producing them. The universe has more tricks than we've catalogued. This is part of the value. The search for intelligence doubles as a survey of cosmic phenomena. We map the radio sky, catalogue the unusual, build databases of what the universe does naturally. The WOW signal from 1977 remains the most intriguing detection, a strong narrowband signal lasting 72 seconds, never repeated, never explained with certainty. Probably natural, possibly a comet, maybe something else entirely. The signal came and went. We were listening. We caught it once, then silence. That's the nature of the search. Brief glimpses, ambiguous data, the need for repetition and verification. One signal isn't enough. We need persistence, patterns, something we can study and confirm. The search has expanded beyond radio. Optical SETI looks for laser pulses, brief flashes that might carry information. Lasers can be powerful, visible across interstellar distances, a different way to send messages. Some searches look for artifacts rather than signals. The idea that advanced civilizations might build structures we could detect. Dyson spheres capturing stellar energy, megastructures that alter how stars look from a distance. Surveys have found unusual stellar behavior, stars that dim irregularly, systems that don't fit standard models. Tabby's star became famous for its strange dimming pattern, probably dust or debris, possibly fragments from a shattered planet. Not aliens, but interesting, worth studying. The search for artificial structures helps us understand natural ones. Planetary formation, stellar evolution, the messy reality of how solar systems develop and change. The question of what we'd do if we found something remains open. Protocols exist, guidelines for verification and announcement. The process would be careful, deliberate, multiple confirmations before any public statement. Finding a signal would be just the beginning. Decoding it could take years, understanding the intent behind it even longer. Communication across light years isn't a conversation. It's an exchange of monologues, separated by decades or centuries. We might detect a civilization and never communicate with it. The signal itself would be the discovery, proof that intelligence arises elsewhere, that we're not unique. That would be enough to change everything. Or we might find that we're alone in a vast empty galaxy, that intelligence is so rare, so unlikely, that it happens once and only once, that Earth is precious beyond measure. The only place where matter has organized itself into minds that wonder about their origins. Both possibilities are profound. Both would reshape how we see ourselves and our future. The search continues because not knowing is harder than searching. The question pulls at us, demands investigation. We have the tools now, the telescopes, the processing power, the methods. Giving up would mean accepting ignorance we have the capacity to address. That's not how curiosity works, not how science functions. We ask questions we can investigate, then we investigate them. The Fermi paradox might resolve in our lifetime. We might detect biosignatures on nearby exoplanets, find chemical evidence of life in alien atmospheres. That would be extraordinary, a form of answer. Or we might find technosignatures, artificial signals, evidence of engineering on cosmic scales. That would be transformative, proof that intelligence arises and persists. Or the silence might continue. Decades more of searching, better instruments, wider surveys. Still nothing. That outcome would be meaningful too. It would tell us something about how rare we are, how special this moment is. The search itself has value beyond its results. It represents humanity at its best, curious, cooperative, asking deep questions about existence and meaning. Thousands of people contribute to SETI, astronomers and engineers, volunteers processing data, donors funding searches, people who want to know the answer, even if it takes generations to find it. This patience is beautiful, this willingness to search for something we might never find, to ask questions that might outlive us, to begin projects that our children or grandchildren might complete. The Fermi paradox sits at the heart of how we think about the future, about what intelligence does over long timescales, about whether the universe is full of life, or whether we're impossibly rare. The answer shapes everything: how we treat our planet, how we think about our responsibilities, whether we're stewards of something common or guardians of something unique. We don't know yet. The data is incomplete, the search ongoing, but the question itself has already changed us, made us think bigger, look farther, consider possibilities that expand what it means to be human. The stars are still there, silent, waiting, full of planets we're learning to study, full of possibilities we're learning to investigate. We listen, we watch, we search, not because we expect easy answers, but because the question matters, because wondering about our place in the universe is part of what makes us human. The silence might break tomorrow, or it might persist for centuries. Either way, we keep looking, keep asking, keep reaching across the darkness toward whatever might be out there, or toward the profound realization that we're alone, that this pale blue dot holds something irreplaceable, the only minds in the galaxy wondering about other minds. Both possibilities fill me with a kind of awe. Both demand that we pay attention, that we take care of what we have, that we keep searching for understanding. The Fermi paradox remains. The great silence continues, but the search goes on, patient, persistent, hopeful in a quiet way. The universe stretches out in every direction, hundreds of billions of galaxies, each containing hundreds of billions of stars. The numbers become almost meaningless at that scale, but they represent real places, real possibilities. Every one of those stars is a potential sun for worlds we'll never see, planets forming, evolving, perhaps developing life in ways we can't imagine. The sheer scope makes it feel impossible that we're alone. Yet here we are, listening to silence. The paradox cuts both ways. If life is common, where is everyone? If life is rare, why did it happen here? Both questions lead to the same feeling of standing at the edge of something vast and unknowable. We've only just begun to look. SETI has been searching for about 60 years. That sounds like a long time. But on cosmic scales, it's nothing. A single human lifetime against billions of years of galactic history. The galaxy is 25,000 light-years from center to edge where we are. Radio waves travel at light speed. A signal from the far side would take 50,000 years to cross. We've been listening for 60. Maybe we're early. Maybe intelligence is common, but young everywhere. Civilizations rising on thousands of worlds right now, all wondering the same thing, all listening to the same silence, all thinking they might be alone. Or maybe we're late. Maybe the galaxy was full of voices once, millions of years ago. Conversations we missed by arriving too late. Civilizations that rose and fell before our sun even formed. Time is strange when you think on these scales. Everything that seems permanent is temporary. Stars burn out. Galaxies drift apart. Even the universe itself changes over time. We exist in this particular moment, with these particular tools, asking these particular questions. The answers we find will be shaped by when we're asking. The search will continue long after we're gone. New telescopes will scan deeper. New methods will emerge. Future generations will listen with instruments we can't imagine yet. They might find something, or they might find more silence. Either way, they'll keep looking, because the question persists, because not knowing is part of being human. We are the universe, trying to understand itself. Matter organized into patterns that wonder about other patterns. Consciousness emerging from physics and chemistry and time. That might be common, or it might be vanishingly rare. We don't know yet, but we're here, we're asking, we're reaching across the darkness with radio waves and hope and carefully designed instruments. The Fermi paradox remains unsolved. The great silence continues. But the search itself matters. The curiosity that drives it, the patience it requires, the willingness to ask questions that might take centuries to answer. We stand on a small world, looking up at an enormous universe, wondering if anyone is looking back. The answer is out there. somewhere in the data we haven't collected yet, in the signals we haven't heard, in the discoveries waiting to be made. We'll keep searching, keep wondering, keep listening to the stars. Thank you for being here tonight. Good night.